Okay. Let's just confirm that you can see my screen.
Yes, we can hear you and see your screen.
Oh, okay, perfect. So thanks for this opportunity. So as we're saying, I'm Rafael, postdoc researcher from University of Campinas in Brazil. I'm doing for 2 years, I'm working on this project called Umbra. And today I'm going to talk about what are the challenges about simulating fabric networks and then debugging the applications. So the agenda will involve the issues that I realize when I'm experimenting with blockchains and decentralized applications in a way that we could create a certain set of requirements for blockchain experiments. I'm going to talk about Project Umbra, where it came from, what we did, and some quick demo, and some outlook about testing blockchains and dApps, decentralized applications. So here's a little bit about the issues that at least I have been facing when I'm trying to experiment with blockchains and dApps. And I'm talking here since the beginning. So a bit about blockchains that we know is that we are trying to, blockchain came around and there's some new mechanism for consensus. We know that non-trusting counterparts can reach agreements through blockchains. We know that there are smart contracts that we can enable some programmable logic on top of this blockchain. And then blockchain started to becoming some sort of middleware for decentralized applications. Now we know that the blockchains are being used everywhere and in different projects, APIs, and especially in different use cases worldwide in production and in lab experiments. So given that, there are certain use cases that require different functionalities from blockchains, I believe, such as supply chain, identity management, and so on. Given that, this really quick intro about blockchains and dApps, the scope of this talk will be about blockchain. Let's say a blockchain enthusiast would like to develop and test some sort of a new blockchain platform, new consensus algorithm, a security mechanism, a decentralized application, or even check if it's new, her new use case is working well. So in order to do that, we'd like to write down some tests for these applications. So this test usually is like we're running blockchains and we like to run these blockchains in scale. So I'd like to perform some tests regarding certain parameters such as the scale or the load of these blockchains, and then what's the performance, how much is, how many transactions per second would I get from the network, and what if my network would be in somehow disconnected from part of time or partially, and the problem of partition here comes to mind. And I'd like to check some security issues, probably checking some collisions and corruptions of my blocks. So somehow what I really would like to desire here is some sort of extensive modification of the parameters that would trigger these tests, and to check them extensively. So possibly I would like to make these tests continuous and targeting production environment. So what happens nowadays, what I see is that there are some platforms around, and there are really specific platforms for particular blockchains and different use cases. And usually what people do is, when I talk to some people that develop on blockchains, they create their own setups in their laptops or their own machines, and or even the cloud, that is really custom for their use case, and they're starting testing with Dockers, like containers, and somehow this makes difficult to share tests, share results, share use case, and especially compare. And when you think about research on top of this, like operational research and extracting metrics from that, we see that it's it's really hard to make this test reproducible. So here I come to the why I would like to see some testing requirements for blockchains and even decentralized applications, in the way that, especially nowadays that we have blockchains running everywhere, I would like to see blockchains like portable, interoperable. So I'd like to test, be able to test blockchains, even especially in my own computer. So, and this way it would give me the features of being able to reproduce my tests, and so sharing with peers and review them and compare these results. So in such a way that even if I could run a test in my own computer, if I'd like to run similarly in different computers, I could scale this test. And this test should be simple and comparable. So in a way that I could write down in a simple manner, run tests and compare them afterwards. And for that, I believe that the way that we define the test should be really easy to configure. So make the settings really easy to define, and then make some quick custom setups. So taking this into the mind, thinking about what happens nowadays for Hyperledger Fabric, we see that the Fabric has its own way of defining what is a blockchain for it, and then how it operates a blockchain. We know that it changed now in the release 2.0, so there's some special functionalities for gene code lifecycle, private data, and channel capabilities. And usually what happens nowadays when you read the Fabric documentation is that you see that we have, initially we had some build your first network, now we have a test network, and these are really well defined Docker Compose files that we can run and create the crypto material and a set of scripts to do that. We see that if we'd like to push here the testing requirements for blockchains that stated in the previous slide, we see that it's really hard to check this, and then in the current status of a test network, because the topology is fixed, we need to understand the configuration in detail somehow if we'd like to customize it. Usually the chain code developer is confined to that environment, so if she needs to change that, it's really hard. Somehow there is no resource allocation guarantees for the nodes or the links interacting that network, and comparing and reproducing the work somehow can be difficult, especially if users start to making change into this format of the experiment. And one tool that existed, for example, that was now deprecated is Hyperledger Composer. But even there were some issues with how the test would be reproducible and compared to each other. So what came to mind initially long ago was like I saw that Project Umbra existed. And here I'm going to talk a little bit about how Umbra became to existence and what are we doing now. So for those who don't know, Umbra is is under the Hyperledger Labs umbrella. In 2018, there was an internship project created for Umbra using the Shadow simulation platform. The project basically stalled because there are some difficulties in importing some libraries for all of our different blockchain projects in Hyperledger. So in 2019, I contacted Dave Huseby, and I said, hey, I'm pushing some experiments here, and I'm using this platform called Mininet that's usually for software-defined networking experiments, and I think I can solve this issue. And he gave me an opportunity to do that in an internship in 2019. So I created the whole Umbra, let's say first, I would say alpha release with a proof of concept for Fabric 1.4 successfully. And this year we got 3 internships in the Hyperledger internship program. And I'm going to talk about them later. And what we see now is that Umbra proved that it's successful. And not just that, we see that it's getting maturity because we're adding more features. I'm working a lot on this new functionalities for coding enhancement. And we are going to like just a working case, like moving from really lab project and going to a, let's say, optimized source code and better functionalities, testing, and for example, moving the support from Fabric 1.4 to 2.0 plus. And this somehow is, I'm going to talk today is how Umbra satisfies these testing requirements that I added in the beginning. And to talk about that, and here describing the basics about the Umbra architecture, not getting too much in details. What Umbra has is now it has 6 components. The first 3 of them were coded last year. The following 3 of them were coded. I coded them this year. So what Umbra provides is design. Design is a component that provides APIs to design blockchain experiments in a modular way. So this would be like the creation of a recipes, experiment recipes. And the scenario is the component that consumes this, here it's called a container net because it's a mini net extension, this platform for deploying the actual emulated environments. And here is something really important to phrase that Umbra is an emulation platform, not a simulation. Then we have the broker component that is the center of Umbra, let's say, and it coordinates the deployment and the triggering of events and monitoring of the topology in its events. The agent is a standalone component that can be instantiated in runtime, the topology, in order to generate some anomalies in the let's say deployed components, in the deployed topology. The monitor is the one that would like initially to see, hey, is everything actually running or so? So I created this monitoring component to check the results about the network, the containers, the nodes, and the environment where the topologies are running. And the CLI is newborn. I'm coding it like this month, and it's a tool to automate the experiments with Umbra. We are going to see this in the demo. So under the hood, we see that Umbra is written in Python 3.8. Each one of the components is a microservice. So there are gRPC interfaces and a protobuffer buffer message defining the interaction among them. The topology in general in the design component is a graph. So there are nodes and links with annotations. And events can be scheduled in different manners. The topology and the events can be created based in modular plugins. And this is really important because each blockchain project here is a plugin that is attached and extends the networking, the topology features. So, and this is also interesting because we can extend Umbra in diversity of settings. And one really interesting point here to make is that Umbra provides this concept of environments that define where the components of Umbra are actually executed. So what happens in the life cycle of an Umbra experiment? This is a really simple picture about that. And here I'm gonna walk through each one of the red numbers. So what happens first is that when you download Umbra and install it in your machine, you have what you need to run an experiment. Basically, you use the Umbra design, here number 1. We import the Umbra design APIs to create the set of artifacts that define the topology and these events. And think here as a document. And this document could be shared from everyone that has Umbra installed on them. And with this document only, if the person has the Umbra installed, uh, he could run the same experiments everywhere with Umbra. So what happens in number 3 here is that this document that references the topology, the events, and the artifacts is consumed by the Umbra CLI component. The Umbra CLI component uses this definition of topology to instantiate the environments. This would be number 4 in the picture. So number 4, think here that each one of the environments here is pictured as these gray clouds in the background. Each one of the different environments would have its components instantiated there. For example, in one of these environments that we have an Umbra broker running, we would have Umbra CLI then. Knowing that all the components were successfully deployed in these environments, it grants the proper interfaces to interact with these components, and it contacts here number 5 with Umbra broker and say, hey, now that you are instantiated, please run the experiment for me. And these are the environments that you need to contact, and these are the components running there. And this is the topology and the events that you need to run there for me. And the Umbra broker performs all of that. So number 6, Umbra broker contacts each one of the Umbra scenario components running in different environments and tell them, hey, this is your piece of topology that you need to run. And then number 7, each one of the Umbra scenario components running in a different environment deploys, instantiates the proper topology. So we have here number 7 that each one of the nodes of the blockchain are deployed. Each one of the nodes in the blockchain here are Docker containers and a programmable switch. Think about this as a layer 2 network, and that all nodes are in the same network, layer 2 network, and reachable peer-to-peer. And between the environments, Umbra scenario creates tunnels. Now it creates GRE tunnels. So the nodes are transparently connected to each other in different environments by like they were running in the same machine. Given that, Umbra scenario like says acknowledge that the deployment of the topology were perfectly defined. And then number 8, when Umbra broker realizes that, it contacts the Umbra monitor components if instantiated in each one of the environments and tell them, hey, I got this amount of Docker containers running in this environment that you're running. Please monitor them for me and push the metrics to this address. And then the Umbra monitoring starts pushing this monitoring data back to the broker. Number 9 here, Umbra broker then performs the scheduling of the events. So it can contact here, for example, the nodes in the network and calling the software development kit of each one of the Fabric of the blockchains, for example, Fabric. So using the SDK, Umbra broker reaches the nodes and realizes all the available functionalities that for example, the Python Fabric SDK provides. So create channels, chain codes, instantiate, invoke them, call transactions, and so on. And finally, number 10, all of these metrics that Umbra broker is monitoring is push it to a database and program it to be visualized in a platform. So what happens actually with all of that is really simple. So that's the idea about Umbra, to turn things really simple. So let's say what we would like to work with Umbra. what would we have to do? So I would clone the repository, I would install it. Then I would define the composition of my experiment using the Umbra design APIs to specify the topologies and the events. Then I run this the definition of this to generate my configs and all the artifacts that would be useful to run this blockchain. And then I run the Umbra CLI. And what I need to do with Umbra CLI is just call a simple set of commands to execute my experiments. So Umbra CLI starts. Then what I need to do is consume the output configuration generated from the Umbra design. And this would be just to load the configuration. If I know or I don't know that the Umbra environments have Umbra installed with all the requirements to run my blockchain there, I put the install command. So this is gonna make Umbra CLI to contact each one of the environments and tell them, hey, install all of the clone and install all of these and download the crypto materials and download of the image, the current images to useful to run that. Then we're going to start each one of the components in the Umbra environments, and then we begin the experiment. The begin triggers the execution of the topology, the proper instantiation of the topology, and then the triggering of the events. And finally, we end the experiment when everything stops. Later on, each one of the components are stopped, and if you like, we can uninstall Umbra from that. We exit Umbra CLI, and if you like, we delete the generated config and the artifacts, and the environment is clean as before. So I'm going to run now a quick demo just to showcase this. What I have in my environment here is 2 virtual machines and my own machine, of course, as the main environment. And then before doing that, what I'm going to do is just talk a little bit about the details about Umbra and guide to a quick step-by-step experiment and show what is being done technically in details in Umbra. And here I'm going to dig deep a little bit about the source code, but not too much details. And so Umbra is developed and tested in Ubuntu 20.04. It's written in Python 3.8. There's a comprehensive setup.py install file that install all of the packets needed. We have a make file as well to define the installation of all the requirements for each one of the components of Umbra, as well as each one of the dependencies even for the blockchains that Umbra can run. And this is really modular. So if a blockchain project is extended to be run by Umbra, then there is the need to create this unique file that defines how these dependencies for this project are needed to be installed. For example, downloading the Docker images, the binaries to compile the crypto material, and even the SDK. And we know that Umbra CLI performs the installation of the local and remote environments. And Umbra uses the /temp Umbra for the source configs and the logs. So what happens when you execute actually Umbra? Umbra CLI handles the automated lifecycle of the whole experiment. We need to design the experiments, then we need to build and save this config that references all of the topology and the events and the crypto material. So the Umbra CLI installs and executes all of that, trigger the execution of the experiment per se, and then from there on, the Umbra broker handles the experiment. So in a step-by-step, what we need first is to design the experiment. So we consume the Umbra APIs, and here is the creation of the scenario. Is the abstraction of what contains the topology and the set of events there. And the topology here refers to what would be called a fabric topology, an Iroha topology, an Indy topology, and so on. So it realizes the abstraction needed for each one of the blockchain projects. It defines the instrumentation to create the artifacts for that. It means that, for example, for fabric, when you build the scenario, here the configuration of the design API, it is going to create all the crypto material. It's going to create all the certificates, the keys, download the images, and perform the construction of this reference configuration that already addresses each one of the paths of the nodes and the links. And the events here refer to the SDK interactions, the topology modifications, and so on. They can be scheduled and to run in a specific time during an experiment. And the scheduling of event can define different parameters for that, such as you would like to repeat the transaction many times, a period of time in the experiment, and so on. So what I'm going to do now is going to create these. As I said, I have 2 virtual machines running here. I'm going to showcase how Umbra can go through each one of these red circles to run an experiment. So what I'm going to show here first is the definition of the APIs that is consumed from the Umbra design configs. And here I define the fabric topology. That's how it's going to run. Then I defined my scenario as say it's the set of topology and events here in the scope of the design APIs. Then I have the definition of my environments. I have a default environment for Umbra. That's where the broker can run or other components can run, but usually it's the broker that is instantiated there. And then I have my 2 other environments. I have here this 44 environment that is going to execute the scenario and a monitor component. And I have here the definition of another environment that is also going to have a different scenario and a monitor component. Here I just define how the topology is going to be defined. So I add these environments. I define the networks for these environments. I create a link for among these networks. I say that this network is going to run in a specific environment. It means that all the nodes connected to this network are going to be placed in the same environment. I define then the parameters for the topology itself, like adding the orgs and the peers and the images and the tags of these images for each one of my orgs. Here I have 4 orgs. I define the order for the fabric topology, the CAs, and then I defined here a quick customization for the config TX to generate the configuration of each one of these nodes. Then I add my links to the network. I connect each one of my orgs. I could here also connect different peers or CAs or orders to each one of the networks. And here I define a profile for them called links. This is useful because one thing that I think I didn't mention here is that each one of the nodes and the links can have a resource profile. The resource can have a location of CPUs, memory, and the links could have a look and disk as well, and the links would have an allocation of bandwidth, delay, and packet loss. So think here, for example, if you'd like to emulate a node from 5 seconds away from another, it would be possible. And then we define these profiles, and here we can define the events. For example, here for the Python, the Fabric SDK, we schedule everything, and then we save this environment. And as I said, the Umbra there is a makefile that gives you the freedom to install each one of the components and everything else. So what I'm going to do now is run this. So I have the topology experiment defined. What I'm going to do is create this configuration. This configuration is going to be saved as a JSON here in the path. What I need to do is to now consume this configuration. So in order to do that, I run Umbra CLI. Umbra CLI, as I told you, is the tool that facilitates the automation of the tests. So I load my configuration. So I now have Umbra CLI loading all the scenarios that I need to perform my experiment. If I needed to, I'm not going to do this now because this is going to take a while, but if I needed to, I would call install here, and the Umbra CLI would install each one of these environments for me. But what I'm going to do now is actually start the components. And here is something important because I need the proper permissions in each one of the environments to run them. And I need to define the user and the passwords for each one of these components to be instantiated there. So here I have now my components instantiated in my virtual machines. I have two virtual machines. One is called environment 44 and the other is environment 156. I'm going to show you this later. And then what I need to do now is I need to begin my experiment. And what is going to happen now is, as I said, each one of the environments have the components running. And I'm going to now trigger the instantiation of the scenario in the Umbra broker component. And then this is going to call CLI to reach the broker and say, hey, deploy this topology now and call these events for me. And also trigger the monitoring and start the visualization too. And then we are going to begin the experiment. So if we check the logs, here are like a bit fuzzy, but here's the broker logs, and it's calling the scenarios and all the instantiation of the features there and getting back the experiment and scheduling the events and so on. And then we see that our experiment started. We begin it. We can see that now in a configuration, graphical configuration, because the Umbra broker already created the database, the data source, and the dashboard. So each one of the metrics from the hosts can be pushed now to the database and can be visualized using the Grafana component. And here I have the memory and the CPU usage from each one of the environments, as well as each one of the containers that are running these environments, the CPU and the memory usage. And then I can check if they're actually running here. So this is live, running now. The monitoring is running. I can show you a quick example about how these nodes can reach each other. Here I'm logging in one of the virtual machines. I'm here just showing you that the network is instantiated as a virtual switch. This virtual switch has the interfaces, and among the virtual machines has a definition of a GRE tunnel. And to show you how this is defined, what we can see is that we can check which one of the Docker containers are running. And we could, for example, we see that in the definition of the configuration, we had, I think we had org1 and 3 and orderer running in one machine, and we had org2 and 4 running in the other machine. So what I'm going to do now is I'm going to log inside one of the peers, and we could, for example, ping a node in another org. Let's say here org2.example.com, and they are reachable. So from one machine to another, because they're, as I said, they're tunnel. And here I could say org4 as well, and org3 that is running the same machine. So they're reachable by their names and so on. So they're running. So here's the monitoring component, getting the metrics from the node, the host, and the containers. Here are the logs of the Umbra scenario as well. You can see that it deployed the topology and so on. And then getting back to our experiment, what we need now to finish it, we need to end the experiment, and this is going to reach now the broker component and say, hey, stop each one of the, stop the execution of each one of the tasks that you send to the components. So broker is going to contact scenario and say, stop the topology. And he's going to contact the monitoring and say, stop the monitoring. And then we can see that in the graph here that the monitoring of the components stop, for example, and they're no longer running in the environment. And finally, we can stop the components. I can show you this here as a quick demo that we have the components running in here. For example, Umbra monitor and Umbra scenario are running in a virtual machine. And if we stop these, it's going to trigger the stop in each one of the components in the environments. And we no longer have them running there in any of the virtual machines. And that's it. If we would like to, we could uninstall the Umbra in each one of the environments. And finally, we log out. And then this is it, an experiment with Umbra with our config file. Going back to the experiment, what we had is that the parsing, the deployment, the instantiation, that we had the Umbra scenario deploying the actual nodes and links. The network was created, and so on. I can go back here to further questions. What we have now in development in Umbra, what I'm doing now is that I'm improving the event scheduling to be generic enough for different types of events. I'm creating a Umbra experiment report, so in a way that we can compare experiments, really easy. I'm consolidating the logging and the CLI outputs, so it becomes easier for users to experiment. So in this way, I'm going to create different types of experiment examples. Add full support for Fabric 2.0 because we depend on the Python Fabric SDK, and there's ongoing work to extend that SDK to support Fabric 2.0 fully. There was an internship this year, in the middle of the year, about adding fuzzing capabilities to Hyperledger Umbra. So I'm reviewing the source code and merging it. And also I'm planning to, this year, to extend Umbra for Iroha and Indie projects, because now I'm only supporting Fabric and creating different examples and extend the documentation. There are a lot of future work going on, but for now, this is it. So going back to the presentation, what I'm going to talk now is that the perspectives about experimenting with Umbra. So what I'm really looking forward here with Umbra is that if I have a use case for a blockchain or a decentralized application, I'd like to know the footprint about it. This is really interesting because blockchains are running everywhere. And I would really like to know what would be the footprint of my blockchain network. Amount of memory, CPU, and so on that each one of the nodes are consuming in each one of the host environments need to have in order to run the nodes. I see that this could trigger the monitoring of the nodes and the links in the network. And in this way, I could create policies, even in Umbra, to make the definition of the hyperparameters of the blockchain network in runtime and tune it in a closed control loop. So in this way, I would tune the blockchain in runtime to achieve my key performance indicators for a particular use case. And that was the initial goal when I talked to David Hisby like 2 years ago about why I would like to run this code, this platform. And a perspective about automating tests, what I'm going to achieve by the end of this year is like we are going to run Umbra in hundreds and thousands of nodes. So large-scale experiments. And this way, we are looking forward to push the limits of the consensus algorithms in these platforms, run some chaos monkey engineering, so creating a lot of faults and see how the network is going to behave. And here I'm going to talk about nodes and links, chains of resource, chains of I don't know, working procedures. So in this way, what I see now is that I'm starting to get closer to a big data analysis problem, because there's a lot of data that I'm extracting from these networks in runtime. So I'm starting to use some machine learning algorithms to get insights about what's actually happening in the network and correlate the resources with the blockchain functionalities. And in the Umbra landscape, what I see for the end of this year is that I would like to see that different blockchain use cases would be shared, comparable, and reproducible using Umbra. That we have teachers teaching these blockchain projects through Umbra, running large-scale experiments. I would like to have Umbra that running simple prototypes to define proof of concepts for different blockchain projects. So really easy and automated. So in this way, I would like to have Umbra as a reference platform to somehow validate some blockchains and dApps, and to support in this way multiple blockchain projects. And then finally, is like each one of the use cases that would be built using Umbra would have this footprint defined and have this chaos monkey engineering running, like for the different blockchains and testing them extensively. And in this way, finally, is that we could run this with the way that I showed you, different experiments in parallel for multiple servers, multiple environments. So the key takeaways from this talk that I'd like to share with you is that if you believe it or not, what we have nowadays is like blockchains and decentralized applications somehow, or most of the time, are not usually or really tested in the way that we have these testing requirements defined initially in the talk. Umbra defines the ways of testing blockchains in a simple, fast, comparative, and reproducible way that nowadays I think is really hard to achieve for different blockchain projects. So it tries to solve these testing requirements for blockchains, and especially it tries to solve that with automation, because we need to automate that and test this extensively in a continuous manner for different use cases. And then here, the way that Umbra can achieve that is to define the footprint for different use cases. And in the future, I hope next year we try to run experiments that we extract this footprint metrics, and we start to fitting these metrics and the functionalities of the blockchains into models or methodologies, probably using machine learning to tune the blockchain itself in a closed control loop. I need to talk also about this Hyperledger internships this year. We had a successful internship already finished by Buddy, that he helped creating these smooth fuzzing capabilities in Umbra that is turning on and off nodes and links and changing the resources in runtime. So enabling chaos monkey engineering, basically. I'm running the experiments to scale Umbra in multiple servers and automate that, as you saw today. And there's a really good project going on that is to create a university course for Hyperledger Fabric using Umbra. Finally, my message here is that I see Umbra by the end of this year performing simple, fast, comparative, reproducible, flexible, so on experiments with blockchains. This is a long dream to be achieved. This year we're going to, by the end of this year, I'm finishing now the source code. We're going to have Umbra released with automation, fuzzing capabilities, and scaling features. And in this way, I hope that Umbra will become a role model to teach and evolve blockchains in labs, or even in research, universities, and even possibly in the industry. Here, I need to acknowledge that this work was really supported since the beginning by David Huseby. He was gave me this opportunity since the beginning, creating incentives, giving the opportunity for the Hyperledger internship. So Hyperledger internship was like a catalyst for this project. It couldn't be achieved without the support of them. And that's it. The source code is there in Hyperledger Labs /Umbra. But from last year, this year I'm going to push it by November, December. And if you have further questions, I'm happy to answer. Thank you.
Thank you so much, Rafael. This is wonderful. Such great information and such an interesting demo as well. We do have several questions, so I want to make sure we get to them. I'm just going to share them in the order they came in. So we have Santiago asking if you are collecting the metrics in Grafana via Prometheus.
I'm collecting them via InfluxDB. It was easier to do that because of the APIs, and I also investigated the Prometheus, but it would take me a while to create a plugin for that. I know there is CA Advisor and so on, and Prometheus and Grafana really well integrated for that. I tested them before, but I would like to create a customized solution for Umbra. So InfluxDB fits the needs for that. I didn't need to go to Prometheus for that.
Okay, thank you for sharing the reasoning on that. Then we had Marco ask a couple questions as well. So he says, we had problems here scaling our experiments with Mininet due to limitations on the V switch. How large can the emulation with Umbra be?
Well, this is what we are going to push now. The idea is that a V switch, I came from a networking area, so my PhD was about that. I played with virtual switches and so on for extensively. And actually the footprint of a virtual switch depends on the workload that it's connected to. So think about here that the amount of containers that we're running in a network. So depending on the amount of traffic that these containers are exchanging, the virtual switch is going to operate likewise, depending on this workload of the server and the resources available. For my experience, I have at least let's say a server with 12 cores, 16 gigs of memory, I would run 100 nodes connected to a virtual switch, or even more. So the idea is that we were going to actually investigate what would be the limits, and that was what I was talking about. Investigate the footprint of the use case, and that involves the investigation about how many nodes we can run in a server and how Umbra is going to give support for that. So this is an open question for Umbra, actually.
Okay. And Marco's second question is, do I need to configure each node in the configuration file? Is there an easier way to instantiate large experiments with, say, about 1,000 nodes?
Yeah, this is the next step now. In the design, we need to create a node, let's say by time, like add peer to each org. What I'm going to do now is that creating new abstractions for that. So this way, what I'm going to do is this scaling experiments that I'm running now is create the abstraction that I would like a fabric network with 100 nodes in 3 environments. And Umbra gives me that, and already performs the split of how these nodes are going to be allocated in each one of these environments. And this way I wouldn't need to configure, let's say, write down in the Umbra design API that add peers 100 or 1,000 times.
Okay, then we have a question from Santiago on whether or not Umbra is compatible with Caliper, Hyperledger Caliper.
Well, I was talking this year, actually, in the beginning of the year, in the Hyperledger Global Forum with the developers behind Caliper, and I think it is compatible in a way that, let's say, Umbra now it can be used as a platform to deploy a scenario that Caliper could run on top of. So Caliper could use the scenario deployed by Umbra to perform the performance test that it's needed. And this way we could create the proper APIs to do that. I don't see any issues with that. But of course, there would be the need to investigate that and do some coding.
Something to follow up on then.
Yeah.
What is, from Merlik, we have two questions. What is the difference between Umbra and Mini Fabric?
Well, I was just listening to a Mini Fabric talk before, and before today's presentation. And Fabric, Mini Fabric is as the name says, it's for fabric, and Umbra is for different projects and different blockchain projects, and that's it. And especially in the case of Umbra, we have the better capabilities to define the resource allocations for the nodes and links. And then we have also the fuzzing capabilities that we could turn on and off nodes in runtime and links and change the resources. So we have a better, let's say, functionalities, I would say, to experiment with a diversity of blockchain projects, not just Fabric. Fabric, now I gave the example, but we are going to extend it to more projects.
Is that something that has already happened, or you hope to see it happen?
It's in the roadmap for this year, my roadmap, yeah, in Umbra. So it's actually really simple to do. I just need to finish this scaling and then move that to code.
Okay,
to
great.
Code these features.
And then Merlik's second question was, how does the experiment simulation logs and performance results, how are they collected in order to be visualized using a data visualization tool such as Grafana?
So yeah, there is this component called Umbra Monitor. It performs the monitoring of the environment, the host servers and the Docker containers. And it can even perform the monitoring of the link, how many packets went through some interface, for example. And it's built, I coded this to be customized, so we could define any form of metrics and then their parameters, their, let's say, their units and so on. And this is pushed to an Influx database by Umbra Broker. So Umbra Monitor sends all the monitoring data to Umbra Broker. Umbra Broker collects them, parses this data, and pushes it to the InfluxDB. And all of that goes to be consumed by Grafana to show, as I showed here, the graphics about that. And this is in a stage, in an early stage, because I just coded this like last week. And now I'm creating new visualization methods to showcase different logs, metrics, and there are a lot of things to show. And yeah, that's it for now.
Real quick before I wrap things up, could you just share, if someone on this call wants to get started with Umbra, whether in using it or actually maybe contributing to some of the things you have in your roadmap, helping figure out how it works with Caliper, how can they get started on that? What's the best way?
So the best way is the one showed in the screen now. There's like this, there's the Hyperledger Labs / Umbra. What it has now, it's the work that was defined in Umbra last year, in the internship last year. So Fabric 1.4, and it doesn't have these automation features that I showed now. So because they're being tested by me now to be pushed in mainstream in the project, in the HEPL. So, but in this HEPL, Hyperledger Labs Umbra. It defines already the experiments, how you can run a simple experiment with Fabric, how you can run the network. There's a virtual machine available to the person download it and instantiate a environment already built to run Umbra. But all these features that I showed today is going to be pushed by I think by the end of November this year. So stay tuned in the Hyperledger Labs main mailing list to catch that.
Okay, great. So join the mailing list and check out the GitHub page as well. Thank you so much, Raphael. I am just going to do a couple of announcements here at the end. Lots of people said thank you for the presentation in the chat. So I think this was a really great discussion. And lots of useful information for people to rewatch again and see how they can use and get involved in the Umbra project. Couple just announcements here right before we end. We do have some upcoming webinars. Simba Chain will be the next one, and then following that, another one on Swisscom. So be sure to register for those and mark them on your calendars. They are also recorded, as always, so you can watch them at other times as well. If you're looking for more content on just what's going on in our community about Hyperledger projects or use cases, you can visit our YouTube channel and also our website as well, where you can see all the webinars from previous sessions. There's just a lot of content there that you can explore. And please get involved. You know, go look at our wiki page, join the Umbra mailing list there on wiki.hyperledger.org. Join the chats where you can also get involved in the community there, and check out all the information that Raphael shared about the GitHub page as well. You can find any project or working group or special interest group at Hyperledger at any of these resources. Thank you very much. This concludes the webinar, and we hope to see you again next time.
Thanks, Karen.
Thank you.